What's up, guys? I've got a longer but still accelerated video for us to look at on the washer method revolving around other axes. This is definitely a topic that's going to come up on the central final, and you'll also probably see some elements of it on the AP test. This is out of Khan Academy's, nearly the last topic that I have to share with you from there. And I want to share with you that I've got this example. We've got it shifted. Here's two curves, y equals cosine x and y equals x plus 1. They're going to be revolving around not the y-axis, but the line that's vertical at x equals -1. So quick sketching them in, and it's good to be able to visualize what these look like. So not only, trying to like accurately represent them or semi-accurately represent them, we also want to be able to think about what it would look like if you did revolve it. What sort of shape do you get? That way your answers are somewhat believable. Any of these revolutions involve the volume formula for a circle. Since we're shifting, in order to use our resources, the previous example said shift it to an axis. So we're going to shift that whole line, x equals -1, we're going to shift it to the y-axis, which means everything has to move to the right one space. The way you do that with the transformation of functions is you subtract 1 from inside the x of the function. Now, this is a vertical rotation. So in order for it to be a vertical rotation, we need to actually have functions x equals something something y. So every function, both of those functions have to be solved to get x by itself and in terms of a y function, a y variable. I'm going to quick sketch it. It's a washer method. So again, that's like the thing that goes around a bolt and secures pieces together. And you kind of get that idea of, oh, this looks like a volcano. Yeah, right? So it's got like, steam coming out of that open hole at the top, and it's got like this, hollow area where like all the lava is going to be building up. Yeah, like a mountain with its top cut up. This is, again, like I said, imagery. Oh, volume formula, base times height. So pi r squared, well, r is actually, for a washer, the outer radius minus the inner radius. So watch a previous video if you need to on what that looks like. But I want to do outer radius minus inner radius. And so the outer is that blue function that happened on the furthest away from that line graph. And we square it because it's pi r squared. So both of the radii are squared, taking out that middle, and we have an answer. Don't forget to look at your options in Khan Academy to know if you need to do like a multiple choice or actually provide an answer. A was my answer. This one has the same structure, rotating around a vertical line. We have the line y equals x divided by 3. And we have the other line y equals 4 minus x. This is totally not drawn with any sort of like equal square scaling. But the key thing is that we're going to take that shape and we're going to revolve it around the line x equals 5. We don't have good strategies for determining how much volume that is. We have the strategy of move it to the y-axis and then integrate. And so that's going to be our process here. Every function, every value has to shift to the left 5 spaces. So inside the function where x is, add 5. Look at this thing again. Oh, it's another volcano! Okay, that was an open bottom! Yeah. Anyway, it's vertical, shift, so we need our functions to be functions of y. And that means solve both functions to get x equals for both. So my first one, I solved x equals 3y minus 5, and in the other one, x equals -y minus 1. So that helps us determine the radius of that washer. One of those is closer to the line of symmetry, closest to that circumference. So that would be our little r. And in this case, it's the blue one. It's the -y minus 1. And then the outer radius is the function within our interval that's furthest away from the axis. And in that case, that's going to be 3y minus 5. Our formula, pi r squared, well, r, remember from previous me in the video, I said r is not r, it's capital R squared minus lowercase r squared, the bigger radius squared minus the littler radius squared. That's the formula for area of a washer. And then we integrate. Use your cheats, calculator, Wolfram Alpha, whatever works for you, in order to help you out right now. Know that you need to be proficient in certainly like some sort of a calculator for the actual AP test or central final. When we're done, integrating it from 0 to 1, that is the height of the volcano, we get 32 pi over 3. All right, I'm going to just, I guess, keep going. I got, 2 more questions to do, and they all have their own uniquities. That's not it. Anyway, the point is, this time, these last two, they're going to be rotations around an x axis or a horizontal axis, but shifted away by a certain amount. So when we bring the two functions back up to the x-axis, rather adding or subtracting, adding to bring the line up, subtracting to bring the line down. And it goes at the end of the function. So we really don't change a whole lot. Like, for example, you see right there, e to the x minus 1 power. We just add 1 to the end of it. Sketching our washer, and it looks like a volcano on its side. So our volume formula, pi r squared. Remember, r squared minus r squared, the outer radius minus the inner radius. You're gonna have to decide and be able to discern for yourself what it is that makes it an outer radius or an inner radius. But it really comes down to what's farthest away from the axis, the rotation. I used some tricks in order to get it. You could probably leave the pi off of your calculation, knowing that you're just going to put pi at the end, back in your answer. So if you integrate that function in the integrate command in your calculator and then just put pi at the end, you can get a pretty good fraction that then has pi at the end of it. Here's the last example for me to share with you as we get into our last minute of conversation right here. We got two functions. We're rotating around the line y equals 4, sketching some of the washers, and it begins to look like a volcano. Certainly there's other things that it should look like, but the point is that it's that idea of like of a rotation, and there's this hollow section cut out of the middle. Because the line is shifted above the x-axis, we got to subtract 4 to bring it back down, and then those define our outer and inner radii. So the way that I drew it, I didn't stick with the same blue-red color consistency on what was outside inside. It does come down to you spotting which function is further away. That's the bigger radius from the line of symmetry, which one's closer. And using some Wolfram Alpha or other calculator technology, integrate it, get an answer. Thanks for watching this video. It's been fun making these, and I hope that you've gotten something out of them. Get your math done. Thanks for doing some math with me. Hit a like on this one. And today's date, it's May 4th, so May the 4th be with you. Thanks. Bye.